Hey everyone, you are on the Proxy-Seller channel. My name is Max. Today we're exploring how anti-bot systems are evolving in 2025, how they detect even the most advanced emulations, why headless browsers are still necessary, and how proxies help mask them more effectively. Let's begin with how anti-bot technologies have progressed. In 2025, bot detection has reached a level where it's no longer about just blocking IPs or parsing user agents. These systems now operate at the level of rendering behavior, GPU characteristics, and interaction patterns, building a full behavioral and technical profile of every visitor. One of the core components of this is fingerprinting. Simply hiding headers or using proxies isn't enough anymore. What matters is replicating the context and behavior of a genuine user. Take canvas fingerprinting, for instance. It works by creating a small graphic using JavaScript, reading its pixel data, and converting it into a unique hash. Factors like GPU, drivers, font rendering, and anti-aliasing all influence this, making each fingerprint highly specific. Building on this, WebGL fingerprinting dives even deeper into your hardware. It pulls in data like GPU model, driver behaviors, support for extensions, and 3D rendering responses. Even minimal discrepancies in shader performance can give away the use of automated tools. But it doesn't stop at hardware. Many anti-bot systems now monitor behavioral patterns in real time. Mouse movements, click delays, typing rhythms, and what happens in the first few seconds after a page loads. Bots often appear too mechanical or too perfect. That's where AI-driven behavior emulation enters the scene, trying to mimic real human patterns. But even this is far from flawless. One of the most advanced platforms used today is Fingerprint.js. It combines Canvas, WebGL, audio context fingerprinting, HTTP header analysis, script loading times, and behavioral data to flag suspicious activity. It's already implemented across major SaaS services, payment systems, and anti-fraud platforms. So where do headless browsers fit in, and how do proxies help? Headless browsers have become the standard for automation in data scraping, botting, testing, and even ad tech. They're fast, flexible, and highly scalable. But there's a catch. They're also easily detectable. So what exactly is a headless browser? Tools like Puppeteer, Playwright, and Selenium allow browsers to run in the background without a graphical user interface. These browsers can load pages, click on elements, and execute JavaScript, essentially mimicking everything a regular user does. The key difference? It's not a human controlling the browser, but code. However, the problem with headless mode lies in its detectability. Even when a headless browser renders a site just like a regular one, it still gives itself away through technical signals. Some of the classic red flags include navigator.webdriver equals true, a direct indicator that the session is automated, lack of GPU-based animations, or improper simulation of motion events, an unnatural structure of the window.chrome object, atypical script execution order, and tab behavior, absence of touch input, or robotic scroll inertia. All of it feels non-human. Anti-bot systems, especially those using machine learning models, are trained to pick up on these subtle anomalies with high accuracy. This is where proxies provide a crucial layer of trust. While they don't directly mask headless activity, they significantly improve credibility at the network level. Residential or mobile IPs can match time zones, deliver expected TTL or ASN values, and come across as much more legitimate. Stealth plugins provide another layer of disguise. Solutions like Puppeteer Extra Plugin Stealth or customized Playwright agents tweak browser behavior to appear more human-like. They patch navigator.webdriver to hide automation flags, simulate GPU animations, inject realistic values into navigator.plugins, adjust Windows object behavior, and introduce randomized delays and interaction patterns to mimic human behavior more accurately. However, even with these stealth adjustments, full anonymity isn't guaranteed. If the IP address is from a known data center range, or the bot activity begins at 3 a.m. from an IP that hasn't shown any prior usage for weeks, that alone can raise suspicion and trigger bot detection mechanisms. Now let's move on to the most crucial segment, comparing a basic bot with a well-crafted, stealth-enabled one. This is where it becomes clear why most bots fail before even completing a single action, and why only a combination of masking, behavioral mimicry, and proper network setup can bypass modern anti-bot systems. When we talk about bots, it's important to understand not every script that clicks a button is equally effective. There's the basic bot thrown together in half an hour, and then there's the sophisticated one, designed to behave like a real user. The difference between the two is massive, and here's what the difference looks like in practice. Let's start with IP address. A basic bot typically relies on cheap data center proxies, for example from providers like DigitalOcean or Hetzner. These IPs are widely used in botnets, which means they're often blacklisted or carry a very low trust score. In contrast, a well-structured bot uses mobile or residential IPs. These are proxies tied to real users or ISPs, offering natural TTL, time-to-live values, and geographic consistency that aligns with realistic behavior. Headless browser. A basic bot typically launches a headless browser as is. While this is convenient, it gives itself away within milliseconds due to indicators like navigator.webdriver equals true, missing GPU animations, and inconsistencies in the window structure. As a result, the website immediately detects it's dealing with a bot. A more advanced bot either masks the headless environment using stealth plugins or skips headless mode altogether by running inside an anti-detect solution like GoLogin or Ads Power. These tools simulate a full-featured browser session, complete with visible UI, GPU support, and all the necessary system characteristics that mimic a real user environment. JavaScript detection. Most modern anti-bot systems don't just analyze IP addresses, they also rely heavily on JavaScript-based fingerprinting. This includes checking WebGL parameters, canvas rendering, audio context output, and touch events. A basic bot often fails to provide this data or returns generic, static values, making it easy to detect. A sophisticated bot, on the other hand, either uses an anti-fingerprint engine or operates through a browser that automatically generates unique, realistic fingerprint values for every session. Fingerprints. A basic bot launches with the same canvas or WebGL fingerprint, instantly marking it as non-human. In contrast, a sophisticated bot emulates a specific device. Screen resolution, GPU, time zone, language, battery status, even acoustic parameters. Everything is fine-tuned to appear organic. Behavior. A simple bot clicks buttons instantly, with fixed timers, no scrolling, and no mouse movement variation. Behavior that doesn't mimic human interaction. A well-designed bot operates with simulated human delays, randomized mouse movements, keystrokes with occasional errors, and inertia-based scrolling. These are the exact details most anti-bot systems scrutinize. Browser simulation. A basic bot often lacks touch event support, has no browsing history, and its window objects appear fake. A refined one, however, mirrors a real user, complete with Touch API for mobile devices, History API, local storage. Everything functions seamlessly. Tools like GoLogin, Multi-Login, Ads Power, and Incognition are built around a simple idea. There's no point in running a headless browser if it's detectable before the page even loads. That's why they work in tandem with proxies, creating a powerful symbiosis for any automation task. How does this tandem work? These platforms enable high-level anonymity and believability by allowing you to create dozens of unique browser profiles with realistic fingerprints, integrate proxies at the individual profile level. This is critical. Each browser profile gets its own dedicated IP address via a proxy server. Operate through Puppeteer, Playwright, and Selenium via API, sync cookies, local storage, and even hardware info. But why is this essential for high-risk automation? If you're building automation where the stakes are high, a basic bot won't cut it. It'll trigger 403 or CAPTCHA before it even reaches the first button. Anti-detection isn't about tricking systems, it's about replicating genuine user behavior. And that requires two pillars: technical infrastructure, IPs, browser fingerprints, and behavioral logic, timing, mouse movements, and reaction patterns. So if you're involved in any of these fields, anti-bot evasion is a must-have. Bot developers. Without advanced anti-detection, any headless browser gets flagged within a few requests. If you're working on an automated registrator, crawler, or clickbot, bypassing fingerprinting and behavioral filters is no longer optional. It's a must-have. Gray hat SEO. When you need to mass check rankings, scrape SERP, or monitor trends, standard tools either can't handle the load or get instantly banned. The solution? Anti-detect stacks plus proxy rotation with human-like behavior emulation. Growth hackers, running mass multi-accounting A/B tests across user profiles, or custom anti-fraud sessions. It all hinges on walking the fine line between fooling trackers and mimicking real interactions. Without anti-bot bypass, scaling is impossible. E-commerce analysts want to check product prices in Poland, Canada, or Turkey. Platforms instantly flag bots and block requests. Without geo-proxies, Headless plus anti-detect and browser spoofing, you won't even load the homepage. AI developers, scraping non-standard datasets, listings, profiles, social interactions, means facing anti-parsing walls. To avoid losing thousands of sessions to blocks, you need to simulate a real user, down to the JS execution and GPU fingerprints. In 2020, anti-bot systems caught bots using simple patterns: IP, user agent, and request volume. By 2025, there are full-blown ML models classifying sessions as human or bot in real time. Systems like Cloudflare Bot Management, trained on billions of requests, now detect whether a user clicks the button the moment it appears or too early, how they scroll, sharp and robotic, or smooth with inertia, if they're using a real mouse with natural micromovements and noise, and if the cursor freezes like headless bots often do. And it goes deeper. AI now analyzes behavior between sessions. It notices when IPs change but click patterns stay identical, time on page is suspiciously consistent, new accounts follow the same registration logic. This isn't about changing fingerprints anymore, it's about fully simulating human behavior. Arcos Labs took it even further. They train neural networks on thousands of CAPTCHA interactions. Their system learns how humans solve visual puzzles, then flags bots that solve them too fast or in unnatural ways. Using anti-detect browsers with proxies isn't just about spoofing technical fingerprints anymore. You need to simulate real human behavior, unique IPs, natural actions, and organic cross-session patterns. Without this, your automation gets shut down real fast. Remember, free proxies pose security risks and lack reliable anonymity, often leading to blocks. For secure and private online experiences, turn to our company Proxy-Seller. We offer 100% anonymity and top-notch security. Our selection caters to various needs, supported by 24/7 assistance. Check the description for a 10% discount code and a link to our site. Don't forget to subscribe to the channel, turn on the notifications by clicking on the bell, and hit the like button. That's all for now. See you guys in the next video.